Alright, we're going to find the area of each of these triangles. We're going to use law of cosines, probably going to use law of sines, and of course the area equations from both sets of notes. So those equations are all the same. So let's take a look and at this first one and see what we've got. A triangle here has a side of 12, a side of 24, and a measurement of 127 degrees, which means we can jump straight into using the area formulas. If you remember, and I'll just give you one of them so that you can recognize and remember what we're talking about, but remember there's three different ones depending on what information you're given. So we had the area is equal to 1/2 A times B times the sine of angle C. Alright, now our triangle is not labeled, so let's label it and see what we've got. If we take this and call it A, B, and C, that makes this side C, this side A, and this side B. We have side A, side B, and angle C. So we can go ahead and just use this equation. Alright, so the area is going to be 1/2 times A, which is 24, times B, which is 12, times the sine of angle C, which is 127 degrees. Punch it in, and you get 24 times 12 times the sine of 127 and divided by 2. You get 115. So our area is equal to 115 square units, or whatever they may be. Alright, so that's the first one. The second one that we've got gives us two angles and one side. That means that finding this angle is pretty easy, but it also means that we need to establish, if we want to use this type of equation here, we need to establish this side here so that we have that internal angle. If we do this side, then we have to figure out what this angle is, which is actually pretty easy to do. But let's go ahead and label it first to make life a little easier. And we'll say that this is A. We'll call this B and this C, making this side B, this side C, and this one is A, which we already have a value for. So I'm going to use the law of sines in this case, because I have this ratio here, alright, and we know, since we're looking for this value, or actually we're going to look for this value because we have to create that ratio. So let's go with A divided by the sine of A is going to equal, in this case, C divided by the sine of C. A is 17.9 divided by the sine of 76.3, and that is going to equal C, which we do not have, but we do have the angle C, so we'll take the sine of 42.8. We need to go ahead and multiply both sides by sine of 42.8. Those will cancel out, I'm left with 17.9 times the sine of 42.8, all divided by the sine of 73.6 equals that side C. I've got the little calculator, which goes to 17.9 times the sine of 42.8 divided by the sine of 73.6. Oops, I hit 9. Let's go 6 and hit enter, and we get a side C of 12.7. So now we've got this is equal 12.7, and we can go ahead and use one of our area equations now, where we need to use side A, side C, and we need the sine of B. So we need to figure out what B is first, right? Because here's what the equation I want to use is area is equal to A times C times the sine of B. Fortunately, B is really easy to solve for. So we've got B is going to equal 180 minus 76.3 minus 42.8. Going to cheat a little bit here and go 180 minus 76.3 minus 42.8 gives us 60.9. So here we have 60.9 degrees. Now we've got a value to plug in here. So our area is equal to A, 17.9, times B. Oh, we're not doing B, we're using C, times C at 12.7. And that's going to be times the sine of our angle B, 60.9. That goes right back into our calculator. 17.9 times 12.7 times the sine of 60.9. And we get 198.6, and that would be whatever our units are squared. So there you have it, a couple of examples. Hopefully you find them useful.